Hello. In this video, we're going to continue with our CAD simulations using LTspice, but we're going to concentrate on the power supply rejection ratio. So the power supply rejection ratio is a measurement to figure out how susceptible our amplifier is to variations in the power supply. So to test this, you can change the power supply voltage and measure the output. If your circuit has two supplies, you're going to want to vary each supply independently. So if you keep VEE constant, you would vary VCC, and then you would go back and keep VCC constant and vary VEE. And then you would find the worst case scenario out of the two, and then do calculations. So I wanted to bring up this document, which is going to be in Canvas, and it goes over the power supply rejection ratio. I recommend reading it because it's going to come in handy not just for this lab, but for all of your labs, and it gives you the formulas and how to simulate and measure the power supply rejection ratio. So looking at our circuit, the circuit that we've been using for these lectures, tutorial videos, is a single supply, right? So 20 volts at VCC, and VEE is tied to ground. So one way that we can do the power supply rejection ratio is just by varying this between 19 and 20 and seeing the change in the output for the two values of the power supply voltage. So what we're going to want to do is pull up a SPICE directive, and we're going to do a step directive similar to when we varied the load. And then so right click on step, and we're going to name the parameter vSupply. So instead of stepping the load, we're going to step the supply voltage. We're going to make our start value 19, our stop value 20, and we're going to increment it by 1. So we're just going to have two waveforms on the plot. And then now that we've done this, we're going to want to right click on 20 and then name it vSupply in curly brackets. And then we just need to bring up a transient analysis. And then now we can run it. So we ran it, and we're going to measure the output, and it shows us the two waveforms. So remember, with this step parameter, the first value is 19. So this blue waveform is the output for when the voltage of the supply is 19. And then the red waveform is the output when the supply voltage is 20. So one way to see this more drastically is if we changed it to 15 volts on the supply and we incremented it by 1, we would get 5 waveforms. And we can see that when the supply voltage is 15 volts, the output voltage is much smaller. So this circuit is pretty susceptible to variations. I'm going to go back to 19 and 20. And then we're going to want to measure these two. So one thing you can do is click on the waveform plot and then go to plot settings and select steps. And then we're going to just select 19, press OK, and then measure the output. and I'm going to save this value. This is our output value, peak to peak. I'm going to save it in the Excel file, and if you don't have an Excel file, that's fine, just save it on a piece of paper. And now go back to the plot settings, go to select step and select the next one, and measure the output. And I'm going to save this value. Okay, so 2.1974 was when the supply voltage was 19, and 2.2773 was when the supply voltage was 20. So now we need to figure out what our gain is. And so our simulated gain was at normal operating parameters, which would be 20 volts for the power supply. The output was 2.2773. And then the input voltage was 20 millivolts peak to peak. And that will give us our simulated gain, which is 113.864. Okay, so now we're ready to do the power supply rejection ratio linear. And so the formula for that, to get the linear power supply rejection ratio, is the change of the supply voltages over the change of the output times the gain. And to do that, I'm going to just write it out at first, just in case anyone's not familiar with Excel. So we're doing the change in the supply voltages divided by the change in the output voltages times the gain. And this will give us our linear power supply rejection ratio. So instead of writing all this in here, if you're not familiar with Excel, you can just click on the values. So 20 minus 19 divided by 2.2773 minus 2.1974 times the gain. And then you press enter and we got the same value. Okay, so now we need to convert it into decibel form. And to convert it, you just do 20 times log the linear power supply rejection ratio value. And you would do that by going 20 times log power supply rejection ratio is equal to 63.07 decibels. And then again, to get like the most accurate result, you would want to have as many significant figures as you can. And that is the power supply rejection ratio. Also, if you don't have experience using Excel and these formulas are written on paper, that's totally fine. I would recommend using LaTeX if you have experience using LaTeX to write up your formulas. And LaTeX, there's a website called latex.codecogs.com, and you can write up your formulas. And then what I do is I just take a screenshot of it, and then you can include that in your report. I hope this helps. Thank you.